Hello everyone, this is now question 70 on assignment 18 from Silverberg. In this question here, you're told that you have a voltaic cell with nickel and cobalt with the following initial concentrations of nickel with 0.8 molar and cobalt we have 0.2 molar. And you want to find, for part A, E of the cell. So we know our equation for E cell involves E naught cell minus RT over ZF ln Q. So there's a few things we have to find in here, one of them being E naught cell, Z, and obviously Q as well. So think about what Q is. Remember, Q is our products over reactants. So we need to know what our actual reaction is in this case here. So you're given the nickel and the cobalt. So if you go to your tables and find the reduction potentials for each of these, so you know they're the metallic nickel to nickel 2 plus, or vice versa, and then cobalt as well. So the reduction potentials you're going to find in the table, nickel 2 plus 2 electrons going to nickel. And the value for that one out of the table is minus 0.25 volts. Similarly, go and find the cobalt one out of the table, and you end up with minus 0.28 volts. So this here is telling us which direction it's going to be going, because you're told in the question that it's a voltaic cell. So we want this to go in the spontaneous direction. When you're looking at that, then you want overall to have a positive number when these guys are added together for the correct directions here. So you're looking for the most positive one is going to go in the reduction direction. So this one right here is going to be the reduction. So that's our cathode. And this one here is now oxidation, or our anode. So a couple ways of finding E naught of the cell. We can do our equation where we have E of the cathode minus E naught of the anode. And in this case here, then, we're going to have minus 0.25 minus 0.28. Do this, you end up with positive 0.03. So this is spontaneous, this is voltaic in that direction. We can also write down the full balanced equation in this case here. So we know the nickel is going in this direction, in the reduction direction. So that means the cobalt will be oxidized going in that direction. So we'll write down the full thing that's going on. We have nickel 2 plus cobalt going to cobalt 2 plus nickel. So at least now we know our reaction, so we can figure out Q up here. So knowing the reaction, I want to go up. We know that, first of all, nickel does not show up any metals like this, any liquids, water, but our ions, aqueous, and any gases will show up. So we're going to have the concentration of cobalt 2 plus over concentration of nickel 2 plus. That's going to be what we're going to use for Q. And those are given 0.8 and 0.2. We now found our E naught cell, which is 0.03. Z in this case, you get from the balanced equation. We didn't really have to fully do it out here because we had 2 electrons and 2 electrons. Those guys cancel. So Z will be 2. You know R and F, and T is just at 298. So that's how you would get E naught cell. And in this case here, or E cell, sorry, the answer you should be getting is 0.048-ish. Now, let's move on to part B. Just need to add all those in there. So erase this. Okay, so part B says, now what is the concentration of nickel 2 plus when our E cell reaches 0.03 volts? So when we're at 0.03 volts, that is also the value of our E naught cell. So if you go back to your original equation, and actually I probably shouldn't have erased it, let's keep it up here, minus RT over ZF ln Q, these guys are now equal. So we have the 0.03 equals 0.03, and then minus RT over ZF ln Q. So it's just going to end up canceling each other out. So what you end up with, 0 equals minus RT over ZF ln Q. And what this breaks down into is really 0 equals ln Q. So that's telling us that Q has to be 1. For Q to be 1, remember Q is concentration of cobalt 2 plus over nickel 2 plus. So it means that these guys need to be equal. So how do we get to that stage then? Well, we started out, we had 0.2 and 0.8. So in order for these guys to be equal, cobalt 2 is going to have to increase, nickel is going to have to decrease. So we know that our cobalt 2 plus is starting at 0.2 plus some amount, and nickel 2 plus is starting at 0.8, and it's going to lose a certain amount. Because they're in the reaction together and they're 1-to-1, whatever cobalt gains, nickel loses, same number. So that is X in this case here. So now you're pretty much just breaking these guys down. These guys have to be equal, so that means you have 0.2 plus X equals 0.8 minus X. So you can solve for X, and you find out that that is 0.3. So that means that your new nickel 2 plus concentration is going to be 0.5 molar. Moving on to part C. Now part C asks, what are the equilibrium concentrations of the ions? So we are now at equilibrium. And when we're at equilibrium, E of our cell equals 0. So that means we're following our regular equation up here. Now we have 0 equals 0.03 minus RT over ZF on Q. So looking at this, actually, I'll replace on Q right now. We know that's going to be some concentration of cobalt and some concentration of nickel. So in order to get down to 0, then obviously this number needs to be larger. That means that the cobalt is going to have to increase and nickel is going to have to decrease. Okay? So we know cobalt 2 plus has to go up and our nickel 2 plus has to go down. So we do something similar to what we just did on B, where our cobalt 2 plus is going to be 0.2 plus X, and our nickel 2 plus is going to be 0.8 minus X. Just the same, because remember, for every one of these gained, one is lost over there. So you can fill everything in, and we'll do partially for you guys here. So now coming from there, we have minus 0.03 going to equal minus 8.314. I'm not going to put units in for now, but remember on your test and stuff, you have to add all of your units. That is 2.6485 coulombs per mole. And then you're going to have ln of 0.2 plus X over 0.8 minus X. There's all the values that we have in there. You're going to go through, solve for X. If you do have problems with that, by all means, ask one of us to go over this with you. I won't write it all out now. When you do eventually find X, you should have a value of about 0.712. It all depends on which numbers you kept, how many decimals you're keeping. So with that, Your final concentration of cobalt 2 plus should be about 0.91 molar, meaning that your nickel 2 plus concentration should be about 0.09 molar. And that's it for this question.